Okay, we're going to solve this system of equations. So first step is to graph both inequalities on the coordinate plane to find the boundary lines. So we're not going to do the shading yet. We're just going to start with the lines. All right, so let's start with this first one. I'll put this in blue. Okay, so y is less than x plus 2. So I start with my equation y is equal to x plus 2. I identify my slope and y-intercept. So the slope is the coefficient in front of x, which is a 1. And the y-intercept is 2. So I go to my coordinate plane and plot the point 2. And then I count out my slope is 1. So it's 1 over 1. So rise 1, run 1, rise 1, run 1, and so on like this. And then the next thing to do is to make sure that my line is either solid or dashed correctly. And I look at this inequality, it's just a less than, not equal to, which makes it dashed. So I'm going to draw a dashed line through those points. All right, now for the second line, I'm going to do this in red. And this time, our equation y equals 10 minus 3/4 x has a slope of negative 3/4. Remember, it's always the coefficient of x. So even though these are like switched around, they still are. The slope goes with x. And the y-intercept is the constant. So now I go to my y-intercept on 10, and then I'm going to count down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. Down 1, 2, 3, right 1, 2, 3, 4. Okay, so those points are on this line. And then looking at that inequality, it includes the equal to, which makes this a solid line. All right, so there's our step 1 done. The second part now asks us to figure out how many regions are created. How many regions? So what that means is like, if you think of the graph as like one whole region, like one whole space, when we put lines through it, we kind of cut it into sections. And 2 lines crossing each other like this would give us 4 sections, right? There's a section here, there's a section here, there's a section here, and there's a section here. And what we want to do is test a point from each of these sections in both of our inequalities. And if the point works in both our inequalities, then that tells us which of these 4 sections is our solution. So our first, let's see, how about we start with this section over here. I'm going to pick a point. I like to plug in zeros, so I'm going to choose 0, 4. There's a good point to choose. So we'll test 0, 4. Okay, and then work my way around. So how about 0, 0 down here? We'll test 0, 0. And keep going, maybe up here on the right. If I can't plug in a 0, it's nice to have matching coordinates. So how about 7, 7? Okay. That way I don't get my x's and y's mixed up. And then something up here like 4, I don't know, 4, 9. Okay. So now we go and substitute these x and y values into our original inequalities. And we have to test both. So remember, this is an x and this is a y. So when I go to plug them into my inequalities, I would have the first inequality would be 4, which is less than 0, plus 2. Is 4 less than 2? Nope. So right away, if you get one that doesn't work, then it's not the solution for both inequalities. So that's like a no. So 0, 4 is out. That is not the one. Let's try 0, 0. I'll put a 0 for y, 0 for x, and this gives me 0 is less than 2. That worked. Let's try the second inequality. Is 0 less than or equal to 10 minus 3/4 times 0? That is 0. So we have 0 is less than or equal to 10. That also worked. We found it. This is the solution right here. So, oops. So 0, 0 is in the solution region. So 0, 0 down here is where both inequalities are true. So what that means is this section is the section that would be shaded by both inequalities. So this point testing process gives us an option of, so we don't have to shade the whole thing for both lines. We just figure out where the overlapping shading would be. There it is.